Our next topic is normal distribution. And for solving the first question based on normal distribution, we have chosen paper 9709/51 for the session May June 25. And we are going to solve the very first question, which says the masses of bags of rice made by a company are normally distributed with mean mu kg and standard deviation 0.14 kg. The probability that the mass of randomly chosen bag of this rice is less than 1.48 kg is 0.22. Find the value of mu. So mean value is missing, and we can start writing our solution. Let us write x belongs to normal distribution. Normal distribution is applicable only for continuous random variable, and the parameters for every normal distribution is mean as well as variance. So mean is mu given here, so let us write mu, and variance is the square of standard deviation. Standard deviation is given here 0.14, so it is simply 0.14 squared. Okay, not 142, it is 14 square. Then the question has provided that probability of the mass of bags which is less than 1.48 kg. Okay, 1.48 kg is the probability is 0.22. Then we will standardize this z-score. Let us standardize this score. It is going to be probability of z less than 1.48 minus mu over standard deviation. Standard deviation is 0.14, and right side is probability, which is 0.22. Now we will analyze the question. If we analyze the question, we will see our probability is the tiny part in the normal graph. Okay, so probability of z, then first of all we'll have to determine the side or direction of z score. Through a graph, if I draw a normal curve is always symmetrical. Then let us shade our probability. Probability is 0.22, and it is lying on the left side of z score. So it will be on the left side and very tiny part. Okay, so let it be very tiny part. Let it be over here 0.22. This portion is 0.22, 0.22. Well, if this dark shaded part is 0.22, surely the rest of the part is going to be 0.78. 0.78. 0.78. That means this portion is the probability, or this region is 0.78, because we know that total probability is 1. So probability of this blue shaded part is surely 0.78. Okay, now we will decide our direction of z-score. Z-score has already been decided that this is our z-score. Okay, so our z-score is here 1.48, 1.48 minus mu over 0.14. So what does it means? It is lying on the left side. Okay, it is lying on the left side of mean value. If any z-score lies on the mean value means this one. This is standard deviation when it is 0. Here our z-score is 0. Okay, at this line, midline, the z-score is 0. So if any z-score lies on the left side, it will be negative. That means we have decided that our z-score is negative. Okay, z-score is negative, less than negative. Well, then if we calculate this, we have already decided the direction of z score, which is negative. It is lying on the left of mid value or 0, so it is negative. But now we will have to find the corresponding z score when the probability is 0.22. We are going to use our normal distribution table, in which none of the corresponding probability is given less than zero point 0.5. So what we will do, instead of finding the smaller part, that means 0.22, we will look for the corresponding z-score when probability is 0.78. Z-score will remain same, just the difference is in direction, on leftward or rightward. We already know that our probability is lying on the leftward, so it doesn't make any difference whether we find the corresponding probability of greater part or smaller part. As the graph shows us, all the values are more than zero point 0.5. If you see over here, look at this here, the minimum value given in the table is zero point 0.5, so it is more than half. Always we will look for the greater part, and so we will find the greater part of our probability is 7.78. And for 0.78, if we see the probability 0.78, this one is close to 0.78, that means 7794. If 6 is added to 7794, it is going to be 0.78. That means our corresponding z score is row is zero point 0.7, first column is 7, and final column is 2. So our corresponding z score is going to be 0.772. So this is how we will find the z score. If we don't find exact probability we require, then we will add up the third column. Okay, hence we have got that 0.7794 plus 6, actually 0.7800. So this is our corresponding z score, 0.77 and 2. So let it be written 0.772. It is going to be 0.772. 0.772. And I think you have understood why have we used this negative symbol, because z score is lying on the left side of mean line. If any z score lies on the left side of 0, that is negative. That's why we have used negative. And here point, instead of 0.22, we have found the corresponding z score of the probability 0.78. If you say that here we will write 0.78, actually 0.78 is lying on the right side. Okay, as we didn't make any change to the direction, it is still left hand side. Look at less than z score, so it is lying left side. That's why left side is 0.22. That's why you cannot make change to 0.78. 0.22 will remain unchanged. If you want to write 0.78, in that case your direction will be different. So we are not changing the probability, it is 0.22, as the z score, corresponding z score for 0.22 and 0.78 are same, just the changes in direction, which we have used as negative because this is lying on the left side. Our z score is lying on the left side, that's why it is negative. Now both of them are z score. Look at this one is z score, this one is also z score, so surely they are equal. Let us equate the z score. It is going to be 1.48 minus mu over 0.14. 0.14 is equal to negative 0.772. Well, then we will apply the cross multiplication process, and it is going to be 1.48 minus mu is equal to negative 0.772 into 0.14, or our mu is going to be, if mu is transposed to the other side, it is going to be positive 1.48 plus 0.772 into 0.14. Hence our mu is going to be, if we round it up to three significant figures, it is going to be 1.5 n, 1.59. This is what our mean value is, and that's how we will solve such question. So just a twist in this question is z score is lying on the left side, that's why we have used the negative symbol, and for greater or smaller corresponding probability z score is always same. Okay, just the change occurs in direction, as it is lying on the left side, that's why we have used negative symbol. I think you got my points. Let's move on to the next question from the same paper. We are going to solve question number 4. Let's find question number 4. This is 2, so it may be 4, maybe over here. This is number 5, that means it is 2. This is question number 4 of the same question paper 9709/51 for the session May June 25, which says every Saturday a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation 2.5 minutes. How many competitors would you expect to have times within 1.2 minutes of the mean time? So this is what the question. This question tells us to find the expected value. Expected value means probability into total number of experiment or competitors. So for finding probability, we don't need to find z-score. Z-score is given already by them. That means we will analyze and find out the z-score. So here we won't find z-score from the normal distribution table. Rather, we will find corresponding probability. Let's start our solution. X belongs to normal distribution, and you know the parameters of normal distribution are mean as well as variance. So mean is given here as 32.4, 32.4, and the second parameter is variance, which is square of standard deviation, that is 2.5 squared. Well, then they have told us to find the probability. That means we are going to find the probability of the people who took times within 1.2 minutes of the mean time. Yes, there is a twist over here. Actually 1.2 minutes of the mean time, that means it may be less than 1.2, less by 1.2 from 32.4. That means mean minus 1.2 or mean plus 1.2. So it's a actually range. So we will have to write in this way. It is actually mean. Look at this. They have told 1.2 minutes of the mean time. So 1.2 minutes of the mean is 32.4. So it is going to be 32.4 minus 1.2 minute. Okay, this is the lower value. Then upper value is going to be less than x, less than 30, mean plus 32.4 plus 1.2 minutes. So I think you got my point, that they have told 1.2 minutes of the mean time. Okay, that means it will be either 1.2 minutes less than 32.4 or more than the mean time 32.4 minutes. Now if we standardize this score, it is going to be probability of, how much is it going, if we subtract, it is going to be 31.2. So 31.2 less than x, or it is going to be 33.6. 33.6. Then as usual we will standardize this score. So our z score is going to be probability of 31.2 minus mu. Mu is already given, it is 32.4. 32.4 over standard deviation, as we did in the previous one, over standard deviation, which is standard deviation is 2.5 minutes, so it is 2.5 minutes until our z-score is 33.6 minus mean value is 32.4. 32.4 over standard deviation, which is 2.5. Then we are going to use our calculator for the value. It is our lower bound is going to be probability of, if we divide this by 2.5, it is going to be negative, it must be negative, so negative 0.48 until it is positive 0.48, 4.8, sorry, no, not 4.8, it is 0.48, 0.48. So it is going to be, now we will have to draw our curve. Suppose this is our curve and this is the normal curve. Normal curve is always symmetrical, you know. Then this is our mean value, standard deviation is where 0. So they have told our probability is going to be from negative 4.8, negative 0.48, suppose it lies over here, until positive 4.8, positive 4.8. Okay, so which part is our probability? Our probability is actually this portion is our probability. Okay, we will have to find the probability of this portion. Okay, so this dark shaded part is our area, this region is to be obtained. So this region can be written in another ways. Look at this, it is actually probability of, if we find the, see, sorry, here it is not x anymore, it should be z score. I made a mistake here. We have already standardized, so it is no more x, it is our z score. Okay, now it is going to be actually z is less than 0.48, from which we will subtract the left part, smaller part, minus probability of z is less than negative 0.48. Well, we will just subtract this lower part, and I can show you what it means actually. If I draw another figure, what we will do is, first of all, we will find the area of this region where the probability is 0.48. I mean, this score is 0.48. After that, we will just subtract this portion. Let me show this one. Here, negative 0.48. If we subtract this portion, this left part, this blue shaded blue, yes, let me shade it with blue ink. So from this whole of this, from 0.48, when z score is 0.48, then we will subtract this tiny. So first of all, we will find the probability of whole of this. Okay, then from this we will just subtract this tiny part, blue shaded part, this portion. We will then subtract this blue portion. That's why we have written, when the z score is 0.48, left part of z score, from which we will subtract one more part, which is when z score is negative 0.48. So one after the other, let us find the z score, corresponding probability for this z score. Let me write just below that. Now I would like to show you this blue shaded part in another way. Look at this. Now if you observe the third diagram, in the third graph, look at this, if we want to get this, look at this, these both in the second and third diagram, both the tiny blue shaded parts are equal, surely equal, because we know that normal distribution graph is always symmetrical. So as we don't have any corresponding probability which is applicable for negative z-score, what we do, we actually convert it into positive z-score, and from 1, if we subtract this part, look at this part, if this part, red part is subtracted, then we will easily find the probability of this tiny part of this z score. Okay, I mean probability of this small part. So what we will do, for the tiny part from 1 we will subtract the left part. So let us write. So for the first part, it is just unchanged. Probability when z-score is less than 0.48, probability z is less than 0.48. But for negative z-score, we will have to take, for negative z-score, we will just subtract from 1, we will subtract the left part when z-score is positive. Z-score is less than 0.48. I think you have understood the point I tried to clarify. For there is no probability given in the probability distribution table for any corresponding negative z-score. So this is how we have converted these negative z-score. This negative z-score has been written this way. This portion has been written from 1, from whole of the probability, just we are subtracting the left part, means this red shaded region. This red shaded region is going to be subtracted. Okay, this part is being subtracted from whole of the figure, means from 1 whole probability we are subtracting this, then we are getting this tiny shaded part, because we require this tiny shaded part to be subtracted. Well, then now we are going to find the corresponding probabilities of these z-scores. Our z-score in both cases is 0.48. Okay, so 0.4 is over here, then row is zero point 0.4 and column is 8. That means our corresponding probability is going to be 0.6844. This is what our corresponding probability is. So we will have to just insert this in both cases. 0.6844 equal to 0.6844. Then this is going to be minus 1. If we dissolve the symbol sign, it is going to be plus. Again the z-score is same, so corresponding probability is also 0.6844. If we simplify this, we will get, our result is going to be 0.3688. 0.3688 is our probability. 0.3688 is our probability. But we should not forget that probability is not our final answer to be shown. They have told us to find the expected value. Look at this, how many competitors should you expect to have? So expected value means mean should be obtained. So expected value, the formula for expected value is mean into probability. I mean total number of, not mean, total number of experiment was 600. It was 600, and probability for each person is 0.3688. So we will write x, or expected value, is equal to ex is equal to, expected value is equal to mean, I mean our total number of experiment is 600, and probability for each of this experiment is 0.36. So our expected value is going to be equal to, if we round it up to whole number, it is going to be 200 21 point something. So you can write either 221 people or 22 people. Let us write 222 people because it is more than 221 people. So our expected value is going to be, if you round it up, remember you should end up the answer in whole number. Okay, you may use approximation symbol. I have used 222 people as whole number. You may use 221 people also because calculator shows 221 point something. But as this is number of people cannot be, no object can be, a practical object can be in partial portion. So that's why we have approximated the result. The result will be either 221 people and 222 people. So that's all about the solution to this question. And in this question actually there has been twist. First twist was that they have told, they directly didn't tell the score. That's why we have added, they have told 1.21, 1.2 minutes of the mean time. So first we have subtracted from mean, 1.2 has been subtracted from mean, and then it has been added to the mean value. After that, for z score, 1 is getting a tiny part. For tiny part, always from 1, we subtract that the larger part. For tiny probability, remember always we subtract the larger part from 1. From 1, if we subtract the tiny part, I mean greater part, then we get the tiny part. This is how we have solved this. So this concept should not be forgotten. This is very common and important concepts of normal distribution. So that is our answer is this. Let's see one more question under the same concept of normal distribution. The next question has been selected from paper 9709/52 for the session May June 25, and we are going to solve question number 7, which says kestrels are birds whose adult wingspans are normally distributed with mean 74.8 centimeter and standard deviation 3.2 centimeters. A random sample of 120 adult kestrels are selected. Is selected. How many of these 120 adult kestrels would you expect to have wingspan between 72.4 centimeter and 76.3 centimeter? So it is exactly as same as the previous one. First of all, we'll have to find the probability. Before we write probability, we'll have to write the parameters. So x belongs to normal distribution and the parameters are mean. Mean is 74.8. So 74.8 is mean, and variance is square of standard deviation, that is 3.2 square. So this is our parameter. Now we will have to find the probability of the birds which are 72 from 72.4 until 76.3, 76.3 centimeters. Now we will have to standardize this score. You know how to standardize this score. It is 72.4, 72.4 minus our mean value. Our mean value is how much? 74.8. 74.8 over standard deviation, which is 3.2. Less than x and less than 76.3 minus mean value is 72.4. 72.4 over standard deviation, which is 3.2. Using our calculator, we will find that our z score is going to be, first one is surely negative, or probability of negative 0.75, negative 0.75 until it is no more x. Frequently I am making same mistake. It is not actually x, it is already we have converted to z score. So it is z less than 0.46875. So if we round it up to three significant figures, it is going to be 0.469. 0.469. Well, then we'll have to draw the graph of this scenario. Look, if we draw a graph, let me draw the first graph, this, and the graph is symmetrical along the in the line midline. So our first z-score is negative, so it will be lying on the left side, negative zero point 0.7, negative 0.75, let it be 7. And on the positive side, it is 0.469, 0.4, let it be 0.4. So which part is our probability? Actually, this dark part is our probability. This portion is our probability to be obtained. Okay, this is our probability. If you have not forgotten, then you must understand that this graph is exactly as same as the previous one. That means we'll have to find this midpoint, for which what we will do, first of we will find the probability when z-score is 0.469, from which we will subtract the left part. If we subtract left part, this tiny part should be subtracted. So z is less than negative 0.75. We'll just subtract the left part. You can go back to the previous part of this uh, solution, not this solution. In the previous solution, you will find that how we calculated this. Actually, we will subtract this part, this blue parts. This part is to be subtracted. Okay, and how to subtract this blue part, that has also been clarified. So first of all, we will find whole of this probability of when the z-score is 0.48. So let us write probability when z score is 0.469, 0.469. And for this tiny blue shaded part, what we do, we just subtract from 1. We subtract from 1 as we did in the previous case. I think you remember this. 1 from 1 we will subtract the large part. For tiny part, always we subtract the large part. Large part will be less than zero point 0.5, 0.75. And if I draw another figure, we require this tiny part. Okay, for tiny part, this tiny blue shaded part is required. Okay, let me change the ink. The color is this. Yes, we'll subtract this tiny blue shaded part. So for this tiny blue part, what we do, we from whole of the probability we subtract the larger part. When probability when z-score is 0.7, 0.7, then we subtract from 1, we subtract this probability exactly like this to get this tiny part of blue shaded part. So this part and this blue shaded part must be equal. Well, it is as exact as the previous one. So for this tiny blue shaded part, what will we do? We will just from 1 we will subtract. Here it has been written, from 1 we will subtract the larger part, then we will get the tiny part. So it is going to be first probability. Let us find the first probability. Using our normal distribution graph, we will find when z-score is 0.469. 0.469 is our z-score, then we will find the corresponding probability. 0.649. So column is 0.6. This is column, and 4 is this is row. First row is 0.6, column is 4, and the second column is 9. So our probability is going to be this one, 0.7389, to which we will add up these 29. Okay, So if we add up this 29 from, sorry, I made a mistake. It is not point 6, it is 469. So our column is 4.4. Sorry, our row is point 0.4 and column is 6 and the third column is 9. Okay. Hence our corresponding probability is going to be here 0.6772, to which we'll have to add this 32. So if we add up 32 to 72, it is going to be 804. Hence our probability is 0.6804. 0.6804, and the other probability, our other z score was, first z score is 0.6 804. If you add up, that means total probability is this. Then for the second z score, it was 0.75. Let us see where 0.75, row is zero point 0.7 and 5 is, column is 5, so this one, which is 0.7734. So we have got both of our probability, corresponding probability. First one is 0.6804, second one is point, it was the column was zero point 0.7 was row and column was 5. Okay, so 0.6804 and another one is 0.7734. Let us substitute this value. First one was 0.6804, 0.6804. I think I can write over here. Okay, -1 plus second probability is, let me zoom it out. So these are the values. First probability is 0.6804, then -1 plus 0.7734. If we simplify this, our result is going to be 0.4538. 0.4538 is our probability. But it is not the end of the solution, because they have told us to find the expected value, and you know how to find expected value is multiplied by the total number of birds. Total there were 120, so 120 into our probability is 0.45. Again I'll have to zoom it out. Our expected value is ex equal to, total number of birds is 120, which should be multiplied by each individual probability, which is 0.4538. And finally our number of birds, expected number of birds is going to be, if you multiply this you will find 54 point some. So if we round it up to whole number, it may be 55 birds. You can write 54 birds also. 55 birds is the expected value. Okay, that is what our answer is. You may write it 54 birds, but it must be expressed in whole number. So as this solution is exactly similar to the previous one, I think you have understood better. Then question number B, immediate next question says, the masses of adult kestrels are normally distributed with mean mu kg and standard deviation sigma kg. It is known that 20% of adult kestrels have mass greater than 0.202 kg and 28% have mass less than 0.185 kg. Find the value of mu and the value of sigma. Both the parameters are missing here, so the solution will be a little bit lengthier. Okay, so let us start our solution. X belongs to normal distribution, and our parameters are here mu as well as standard deviation is sigma. So mu and variance is sigma squared. Okay, so first probability is given when when x is greater than 0.202 kg, 0.202 kg, then probability is 20%. So 0.20 is the probability. Probability is given. We will have to find the corresponding z-score. Okay. So if we standardize this score, it is going to be z greater than 0.202202 minus mu, because mean value is missing, minus mu over standard deviation, which is sigma. Okay, equal to 0.20. Well, then we will have to analyze where z-score lies, whether it lies on the left side or right side. Through the graph, we can explain this. If I show through a diagram, look at this. This is the graph. So here our probability is very tiny part. Look at this. It's 0.20 and right side of z-score. Okay. So 0.20, it's very tiny part. That means this dark shaded part is our probability. Okay. And our z-score is surely positive. Here is our z-score. So the probability of this region is 0.2. 0.20. So surely rest of the part, this part is 0.80. It will be 0.80. Well, this portion, the area or probability of this region, red region, must be 0.80. And you know that whenever we find the probability, always we find the larger part. Okay, because none of the corresponding probability is less than zero point 0.5. Okay, so whenever we use the probability distribution table, we will find the corresponding z-score when probability is 0.8. It is similar to the very first solution. Well, then, and the direction or location of z-score is, look at this, it is lying on the right side. So it is, let me show you, it is zero point 0.2 minus mu. Here is 0.2 minus mu over standard deviation. So as it is lying on the right side of 0, so surely this is positive. So our z-score is lying on the right side, so it will be positive. Z greater than, then we will find the corresponding z-score for this probability, and probability is 0.20. As we don't have any probability less than 0.5, look at this, the first probability is smallest probability start with 0.5. So we will have to find the greater probability, but z-score has already been decided, it is positive. Actually left and right is required for the symbol of z-score. Z-score has already been decided that it is lying on the right side, so it's positive. Now let us find when the probability is 0.8. So we are searching for a probability which is 0.8. It may not be found exactly, but we will try to look we will try to find the closest one. Look here, 0.7995, that is 7,995. We require 8,000. So our row is 0.8 and first column is 4. Now as we require 0.8, I mean one more 5 is required to be added. So this is 5. Then exactly it is going to be 0.8. So our answer is 0.84 and the second column is 2. So our answer is 0.842. Look at this. Again, I am explaining that for finding corresponding z-score, first of all, they have told us to find the probability, means we are searching for the probability 0.8. So 0.8 may not be given exactly. We can make it up. First we have found 0.7995 and we have added 5 to that, then it has become 0.8. So our corresponding z-score is 0.8, row is 8, first column is 4, second column is 2. So 0.842, and already we have decided that it is lying on the right side, so there is no necessity of negative symbol. It is going to be 0.842. 0.48, sorry, 842 when the probability is the tiny part 0.20. Well, then look at this, both of these are z score. This is z score and this is also z score, so they must be equal to each other and we can form an equation. And remember, don't write 0.80 in probability is the tiny part. We are such, if you write 0.80, then you will have to change the symbol z less than. As we didn't change the symbol direction, so you should not change the probability. Total probability is 0.20 when z score is 0.842. That means probability is lying on the right side. If we use left side, then you will have to use negative symbol. Remember, don't get confused. Some teachers may tell that use z less than 0.842. In that case, you will have to change the probability also. As we didn't make change any of these two quantities, so it will remain same. Well, so if we form an equation, it is going to be point or 0.202 minus mu over standard deviation is equal to the second z score, I mean exact digital z score is 0.842. Then we can isolate sigma. If we isolate sigma, it is going to be, hence our sigma is going to be 0.202 minus mu over 0.842, 0.842. So this is one of the equation we can write. Equation number 1. There will be two equations because simultaneously two values are missing. Okay, one more equation will be formed. Now let's concentrate on the second part. In the second part, it has been written that 28% 28% of the birds have wings have mass less than 0.185 kg. So let us analyze this. Probability of x less than 0.185 is equal to, probability is given 0.28. 28% means 0.28. Now if we standardize this score, it is going to be z is less than 0.185 minus mean means mu over standard deviation is equal to 0.28. If we observe the graph, look at this. Suppose again our probability is tiny part. Look at this, it is just a very tiny part. It may be, and it is lying on the left side because less than z score, so our z score may be over here, which is 0.18 minus mu over standard deviation. Okay, and our probability is, required part is this is our probability. Okay, and this portion is 0.28. If it is 0.28, so the tiny part which is lying on the other side, red shaded part, this must be 72.72. Okay, 0.72, let us write here 0.72, 0.7 as well as 2. So we know that always we find the corresponding z score of the larger portion. Okay, so for larger portion, yes, and we have already decided that Our probability is this tiny black shaded part which is lying on the mean value. Look at this, mean value is here, it is 0 over here. As our z score is lying on the left side, so it must be negative. So we will have to write probability, our z score is negative, and corresponding z score for the probability, when probability is 0.72, we will find the corresponding z score. Our probability is now 0.72. Okay, so for 0.72, look at this, 0.727271 is here. Yes, 7190, there is 7190, and our column is our row is 5 and first column is 8. As this is 90, we require 10, we can add up this. So our corresponding z score is 0.583, 0.583. This is our corresponding z score when probability is 0.7190 plus 10, means if we add up it will be 72. So our corresponding z score is 0.583. Okay, let it be written 0.583, 0.583, and already we have decided it is lying on the left side of the curve, so it will be negative 0.28. Don't make any change to the probability because we have already seen that it is lying on the left side and we didn't change the direction. It is lying on the left side of the z score, so it will be as same as this. Now both of these, if we look carefully, this is z score. Okay, this is z score and this one is also z score, so surely they are equal to each other, or 0.185 minus mu over standard deviation is equal to negative 0.583. If we isolate our sigma, then it is going to be finally 0.185 minus mu over, yes, we'll have to interchange the symbol, it is going to be negative and it will be positive, so 0.583 over 0.583, it is equation number 2. We have formed two simultaneous equation. Solving the equation simultaneously, we will get that both of them are sigma actually, so minus 0.185, sorry, not minus, or plus mu over 0.583 is equal to, in equation number 1 it was, let's see equation number 1 from the previous page, it was 0.202 minus mu over 0.842. So let it be inserted, equal to 0.202 minus mu, 0.202 minus mu over 0.842, 0.842. Now if we do cross multiplication, we will find that 0.84 mu is equal to 0.84 mu, then minus, if we multiply 0.842 by 0.185, it will be, so it is 0.15577 and double seven equal to, on the other side it is going to be, if we multiply 0.202 into 0.583, it is going to be equal to 0.11776, 0.11, here we skipped 1 2, it will be 0.842, and this is not 0.842 mu, it is going to be 0.583 mu, negative 0.583 mu. So if we add up all the mu's, it is going to be 0.842 mu plus 0.583 mu. It is going to be 1.425 mu. 1.425 mu is equal to, if we add up the other quantities, it is going to be 0.2735, 0.273538, 38. 38. Hence, our mu is going to be, if we divide it by 1.425, it is going to be, if we round it up to three significant figures, it will be 0.192. 0.192. Okay, this is the value of our mu. Then we will find the value of our sigma. Okay, then sigma is equal to, any of the equations can be picked up. Let us pick up this one, 0.02, 0.20. Sigma is equal to 0.202, 0.202 minus our mean value was 0.191. 0.191. I am taking more digits than necessary so that the result may be the most accurate one. 0.191 955 955 over 0.842, 0.842. Hence our sigma or standard deviation is going to be, hence our sigma is going to be, sigma is going to be 0.119. 0.119 if we round it up to three significant figures. Okay, this is the approximated value. So this is how we will solve this question. Let me show the previous page. It was the lower part of this page contains the previous part of the solution, and final part of the solution lies over here. And there is no twist or difficulty in this question, but it is linked there because simultaneously you will have to find two different values, and from the probability distribution table, normal probability distribution table, we didn't find the probability, rather we found the corresponding z-score. Using calculator also you can do this, but I feel comfort solving and applying this value extracting from normal distribution table. This booklet will be provided to you in the exam. Well, let's see the next question. So we have selected the next question from paper 9709/53 for the session May June 25, and we are going to solve question number 2. At a large college, all students who study science also study exactly one of art or drama or music. 20% of the students study art, 45% study drama, and 35% study music. Three students are selected at random from the students who study science. Find the probability that at least one of the students studies drama. Okay. Sorry, we have chosen a wrong question. Paper is correct. It should be actually question number 6, not question number 2. So paper is correct. This is the paper 9709/53 for the session May June 25, but question number will be 6 actually. So let us see question number 6. This is 5, then it is over here, not even over here. Okay, this is our question to be solved. So from paper 53 of May June 25 session, question number 6 should be solved. A company sells bags of pasta The masses of large bags of pasta are normally distributed with mean 2.50 kg and standard deviation 0.12 kg. Find the probability that mass of pasta in a randomly chosen large bag is less than 2.65 kg. Very simple question. Let us solve it. X belongs to normal distribution, and our parameters are here. Mean is 2.5 and variance is 0.12 square. So 2.50 is mean and our variance is square of standard deviation 1 to square. Okay, and we are going to find the probability when a bag is less than 0.265. So less than 2.65, 2.65, and we are going to standardize this score. If we standardize this score, it is going to be z less than 2.65 chosen bag minus our mean value. Mean value is 2.50, 2.50 over standard deviation, which is 0.12. Then using our calculator, we will find that our z score is less than 0.125, 125. And if we draw a graph, it is very simple. Our z square is lying on the right side because this is positive, and they have told to find the probability of the left part. So this is our probability. Okay, this probability should be obtained, and our z score is zero point 0.1. Here it is 0.1, 1.2 or 1.25. Then using our normal distribution table, we will find our corresponding probability when z score is 1.25. Our normal distribution table is over here, and then our z score is 1.25, 1.25, 1.25 is a little bit lower. Yes, so 1.2 first. It is 1.2. Then 5 row is 1.2 and column is fifth column. So it is 8944. Simply we can write 894 if we round it up to 3 significant figures. So it is 894 equal to our probability is 0.894. So the immediate next question says a restaurant manager buys 160 of these large bags of pasta. Find the number of bags for which you would expect. Again, expected value. Expect the mass of pasta to be more than 1.65 standard deviation above the mean. Yes, there is a twist over here. So let us start the solution. Expected value, that's why we'll have to find first the probability. Then it is under the same normal distribution, so there is no necessity of writing the parameters. Let us start. Probability of x is greater than. Okay, it is written that more than more than more than 1.65, more than 1.65 of standard deviation. That means standard deviation above the mean. As it is above the mean, so we will have to add up, and our mean is 2.5. We know. Let us see. Mean was 2.5, 2.5 kg. So surely it will be added to 2.50. So above mean means we will have to add up 2.5, and we will have to add up this 1.65 of the standard deviation. So 1.65, 1.65 of standard deviation. How much is the standard deviation? Standard deviation was 0.12, 0.12. So this is how it should be written. So please don't get confused. Once again, I'm repeating that they have told above the mean, so you will have to add up to the mean. Okay, mean is 2.5, and how much is to be added? It will be 1.65 standard deviation. That means 1.65 of standard deviation. So let us solve this. If we standardize this z score, it is going to be z is greater than, after calculation we will get 2.698. 2.698 minus mu. Mu is given, which is 2.50. 2.50, and our standard deviation is 0.12. 0.12. So our z score is going to be, probability of z score, if we use our calculator, it is 1.65. Surely it is lying on the right side. If you draw a curve, look at this. In this one, our z score is lying on the right side of mean value, means 1.65, and our probability is right side. Look at this. So this tiny part, okay. So for this tiny part, of what we always do, we will just subtract the left part. Okay, if we subtract the left part from whole of the probability, we will get always the smaller part. Okay, so for smaller part, always we subtract the left part, because none of the probability given in the probability distribution table is less than 0.5. So what we will do, we will just subtract the left part. Probability of z less than 1.65. Now we will find the corresponding probability when our z score is 1.65. So our z score is 1.6. This is 1.6 row, and column is fifth column, so it is 9.9505. Okay, 1.6 and 5 is our z score, so corresponding probability is 0.9505. So let us write 1 minus equal to 1 minus 0.9505. Hence our probability, individual probability, is going to be 0.0495. 0.495. They have told us to find actually expected value, and you know how to find expected value. Just will multiply the total number of experiment, total number of bags were how many? 160. 160 bags have been taken, so it is 160 into individual probability of each of bags, 0.04, 0.0495. So our expected value is going to be, if we multiply 160 by 0.0495, it will show more than 7 bags. So you can write 7 bags. If we round it up to whole number, then you can write 7 bags or 8 bags. Okay, 7 bags. So this is what the answer to this part. Let's see the next part. Question number C is, the masses of small bags of pasta sold by the company are normally distributed with mean mu kg and standard deviation sigma kg. Tests show that 77% of these bags have masses greater than 1.26 kg, and 44% have masses less than 1.35 kg. Well, so this is a different normal distribution, so we'll have to write the parameters again. X belongs to normal distribution where the parameters are mu and standard mu and variance. So standard deviation square, that means sigma square. Sigma square. Well, it is similar to the second solution of this topic. So there will be two simultaneous equations for two different cases. First one is probability of x is more than 1.26, x is more than 1.26, probability is when the mass is more than 1.26 kg, probability is 0.77. If we standardize this score, it is going to be z is greater than 1.26 minus mu over standard deviation, which is sigma, equal to 0.77. Now we will have to determine the symbol of z, whether this is positive or negative. Okay, if we draw a graph of normal distribution of this scenario, we will see that, look at this, our probability is more than zero point 0.5. Okay, so for more than zero point 0.5, it will be, but right side of z score, suppose z score is over here, it is 1 point, suppose 1.2 minus mu over sigma, and right side is our probability, this is our probability. That means one thing is very sure, that if we want to get a probability more than zero point 0.5, which lies on the right side of the z score, it that proves that the z score is on lying on the left side of the mean line. That means left side of 0. So it is sure that our probability z score is negative. So let us write negative. Now for probability of 0.77, we will have to find the corresponding z score. So let us go back to the probability table. Our probability is 0.77. So if we see, it is 0.776, closer to 76. Yes, this one is 0.7673. So 27 more is required. Let us see, at least we can find 26, we can find 27, sorry, not 26, we require 27. So we got the exact figure for sorry, for 0.77. Our column is zero point 0.7, and first our row is zero point 0.7, first column is 3, and final column is 9. Okay, so it is 0.73 and 9. 0.739 is our corresponding z score when probability is 0.77. So let us write, it is 0.739, and already we have decided that it is lying on the left side, so the direction is negative, I mean symbol is negative. 0.739, 0.739. Then both of these are z score. This one is z score as well as this one is also z score, so they must be equal if we compare. Or 1.26 minus mu over sigma is equal to negative 0.739. Then if we isolate sigma as the subject, then sigma is going to be, dissolving the symbol, it is going to be mu minus 1.26 over 0.739. We may leave this is equation number 1, and we know there will be two different equations, because there are two values missing. We will have to obtain them simultaneously. Okay, so the next part says, when x is 44% have mass less than 1.35. So less than 1.35, Let me change the color of the ink. X less than 1.35. Okay, it is 1.35, while probability is 44% means 0.44. Well, so let us standardize this score. If we standardize this score, it is going to be probability of z less than 1.35 minus mu over standard deviation is equal to 0.44. Then we will find out the symbol of z score. Look at this. This is the graph. For this graph, our probability is lying on the left side and it is 0.44. Let's say here our probability is 0.44. 0.44 is our probability, means this part, this small part. Okay, so as this is our probability, hence z score is lying on the left side, isn't it? So our z score is just over here, which is 1.35 minus mu over sigma. And as our z score is lying on the left side of mean line, so surely it is negative. Our z score is lying on the left side, so surely it is negative. Okay, so probability z is less than negative. Direction has been found and probability is 0.44. And look, these probability is also smaller part, so always we find the larger part in the probability distribution table, which will be 0.56. So this portion is 0.56. So let us see what is the corresponding z score when probability is 0.56. So our probability is 56. For 56, if we see over here, it is 0.5596. With these, if we add up 4, then it will be 0.56. So our column is zero point 0.1. Our row is zero point 0.1 and column is 5 and another column is 1. So it is 0.151 is our corresponding z score for the probability of 0.56. So 0.151 is our corresponding z score. 0.151. 0.151 is our corresponding z score. And now we will have to, both of them are z score. This one is our z score as well as this one is also our z score. So they must be equal. If we equate, hence our z score is 1.35. 1.35 minus mu. 35 minus mu over sigma is equal to, I think we could have dissolved the symbol, so it is going to be plus and this is minus. Okay, equal to 1.151. 0.151. If we isolate our sigma, then our sigma is going to be, hence our sigma is going to be 1.35. 1.35, sorry, mu plus 1.35 over 0.151, and that is equation number 2. So we are going to solve the equation simultaneously. Let me write just over here. Well, so if we solve the equation simultaneously, it is sigma is equal to mu minus, or you can write here from equation 1 and 2, 1 and then if we do the cross multiplication, it is going to be 0.151 mu, 0.151 mu, 0.151 mu. I think I can write on a new page because it will take much space. Let me see whether there is no, there is no space over here, but here it is a new page. So our equation is, if we simplify this, it is going to be 0.151 mu minus, if we multiply 0.151 into 1.26, it is going to 0.190 19026 equal to 0.739 mu, 739 mu minus, if we multiply 1.35 by 0.739, it will be 0.99765, 0.9976 as well as 5. So if we subtract the mu, it is going to be 0.739 minus 0.151 is going to be 0.588 mu, negative 0.588 mu is equal to, here if we subtract 0.19026, we will get minus 0.80739, minus 0.80739. Hence our mu is going to be, if we divide 0.80739 by 0.588, it is going to be 1.37311, 1.37311. If we write three significant figures, it is going to be 1.37. 1.37 is the value of mu. Okay, 1.37. Then we, applying the value of mu, we can find the sigma, value of sigma. Sigma is equal to, so mu is 1.3731 minus 1.26. If we pick up the first equation, then 0.739. So finally our sigma is going to be 0.153, 0.15 and 3. So these two are the final answer to this question. The value of mu as well as value of sigma. This is similar to the second solution of this topic. Let me show the previous part. This is the present part and the previous part is over here. And I believe that you have understood all these three parts of this question. And before that, it was this, there is one more part, yes, this one. So this is A, then there is for B, this is A is over here. This one was A as well as B. Okay, then C took much space. C is over here as well as over there. So that's all about the solution to the questions of paper 53. Then let's move on to paper 55. The final question has been selected from paper 9709/55 for the session May June 25, and we are solving the question number 2. It says the heights of trees in a certain forest are classified as tall, medium, or small. The heights can be modeled by a normal distribution with mean 20 meters and standard deviation 5 meters. Trees with a height of less than 14 centimeters, 40 meters are classified as small. For 150 randomly chosen tree from this forest, how many would you expect? So expectation, first of all, we'll have to find the probability. So x belongs to binomial, normal distribution, where the mean is 20 and our standard deviation is 5. So variance, second parameter is 5 squared. Okay. Then they have told us to find the probability of classified as small. So small is actually less than 14. So x is less than 14. If we standardize this score, it is going to be z is less than 14 minus mu. Mu is 20 and our standard deviation is 5. Surely it is going to be negative. Our z score is negative because mean is greater than our score. Then probabilities z is less than negative. If we divide 6 1.2, it's negative 1.2. So if we observe the graph, in the graph, look at this, our z score is 1.2 and it is negative. So suppose here there is 1.2 and probability is lying on the left side, means this tiny part is our probability. So for tiny part, always what do? We just find the larger part. Okay, from larger part we will subtract, from whole we will subtract the larger part. That means it is 1 minus probability of z less than 1.2. If I show you another through another figure, it is something like this. We require the small part, this part. So for this small part, here the probability is, z score is 1.2. So here z score is 1.2. Then from whole, if we subtract the left part is, suppose this part. This part is to be subtracted from whole of the probability. Okay. So we will find the corresponding probability when our z score is 1.2. So let us find our corresponding probability when z score is 1.2. So for 1.2, our z score is 1.2. So here there is 1.2. Yes, 1.2. This is 1.2 means 1.20. So row is 1.2, column is 0. That is our corresponding probability is 0.8849. 0.8849 equal to 1 minus 0.8849. Hence our probability is going to be, if we subtract this, it is going to be 0.1151. 0.1151. Now our expected values. Let me change the color. Our expected values is going to be 0.111151 and total number of um, bag, was it bag or what, trees, total number of trees were 150. So let us multiply by 150. So finally number of trees is going to be 17 trees. Okay, if we round it up to whole number, so there will be 17 trees which will height less than, I mean less than 14 meter means small. Let's see question number B. B says trees from this forest are classified as tall if their height is at least 8 meter. 25% of trees are classified as tall. So we are still under the same normal distribution. Okay. So let us write probability of x is at least h. So at least h means it is greater than h. Now you may ask that they have told at least. At least means it will be greater than or equal to. Okay. So greater than or equal to is actually greater because in normal distribution this is continuous, applicable for continuous random variable. So it is actually all the same whether you use equal symbol or not. That means greater part. Okay, is equal to 25%. So probability is given, it is 0.25 tiny probability, or if we standardize it is z greater than h minus mu over standard deviation. Standard deviation is already given, we have used it as 5 equal to 0.25. Okay, then we will determine the symbol of z-score. Let us see, our probability is zero point 0.5, so point, and it is lying on the right side. So definitely this small part is our normal, I mean probability, small probability, and here our z-score is h minus, this is our probability to be obtained, and our this is 0.25, 0.25. So what about the rest of the part? This white part, unshaded part, is going to be 0.75, 0.75. Well, so our z-score is lying on the left side, and if we want to decide this as right side, so it is going to be 1 minus, we will have to find probability z is definitely right side, it is positive. Okay, now while finding corresponding z-score for probability, always we will find the greater probability. I explained it in elaboration in the previous solutions. So let us find when probability is 0.75, 0.75, and symbol about z-score is positive because z-score is lying on the right side, which is h minus mu over 5. Okay, z-score is this, here it is 0. So let us find the probability when probability is 0.75. Let us see 0.75. So let's see here 7486. So 14 more is required. Yes, this one is 14. So our row is zero point 0.6, column is 7, first column is 7, and another column is 4. So our corresponding z-score for 0.75 is actually 6.674. 0.674. So let us write this value. Our z-score is 0.674. 0.674. 0.674 when the probability is 0.25. Don't make change this probability because we have chosen, we didn't change the direction of z-score. Well, now this is z-score. If we compare both of the z-score must be equal, or h is equal to h minus mu over 5 is equal to 0.674. By doing cross multiplication, we will find that h minus h is equal to, or h is equal to 5 into, sorry, our mean value was given, mean value was 20. Why are we leaving it unchanged? Let us write 20. Our mean value is already given, so it is 20. Okay, it is 20. So is here, it is 20, and then here also it is going to be 20. Okay, it is not mu, it is 20. Okay, so our h is going to be 5 into 0.674 plus 20. Hence our h is, the value of h is going to be 23.4. 23.4 if we round it up to three significant figures. Well, so that's all about the solution to question number B of this question. And with this, I am going to end up this topic. I explained every question as much as possible, and I believe that if you have been attentive, you understood every tiny part of the solution. So let's see the next topic, find out the questions of the next topic.